Alright, we're going to look at electricity goal 1. As it says there, we're going to identify the sign and the relative amount of electrical charges and the particles related to those charges. That's one part. Then we're going to describe the changes in electrically charged or neutral objects based on the concepts of electrostatic conduction, friction, and induction. That's what we're going for. It's really a beginning understanding of electricity. Signs of charges, well, you know them well. They're negative and positive. You can see we have an atom over on the right-hand side to help us with that. And negative and positive were named by Benjamin Franklin. He was big into positive charges. He actually didn't talk a lot about negative charges. He talked about the absence of positive charges initially. But eventually he got there. Eventually people got there. Atoms contain both positive parts, those parts in the center, protons, and on the outside, they are negative particles, electrons. You can see labeled in there are neutrons. Those are also part of the nucleus. They have literally no charge. They're not just neutral. They have no electric charge. The charge of one electron is equal and opposite to the charge of one proton. That's actually really important because otherwise the atoms can't be balanced. Now, objects that are negatively charged, whether it's an atom or anything, are electron rich. In other words, they have more electrons than they have protons. The protons are locked into the nucleus. To rip one off takes an awful lot of force. That's what nuclear fission is about. Nuclear power and nuclear weapons. So it takes an awful lot of energy. That doesn't happen ordinarily. What happens is electrons get transferred. They're electron rich. Okay, that's all it means. Positive things are electron poor. They have less electrons than they have protons. That's all that means. Sometimes people talk about conductors and insulators. In terms of electricity, it means something slightly different than it means like for heat. Neutral objects are not really neutral. They're not really without charge, I should say. They have an equal number of positive and negative charges. If you take a look down here down at the bottom left, where the picture of the atom is with the protons, neutrons, electrons, and the nucleus, you can see there's 3 positives in the center, 3 protons, and there are 3 electrons on the outside. So the positive 3 and the negative 3 balance each other out. That's a neutral object. Doesn't mean it has no charge at all. It just means it's balanced. Just like I said, equal number of positive and negative charges. Conductors are going to allow electricity to pass through. You can see in the picture that like one electron goes to the next one and then kicks one over to the next atom, kicks one over to the next atom. They can do that because there's a looser electrical force between the nucleus of the atom and the electrons on the outside. So they're able to do that. They can kick from one to the other. Insulators do the opposite. They actually block the flow of electricity through them. So that means that they're going to have a tighter electrical force between the nucleus and the electrons on the outside. That doesn't mean that they can't be slightly electrically charged. Charges can still collect on the surface. It just means that they won't let charges flow through them like a conductor does. That's the biggest difference. There are 3 types of electrostatic charging. Again, only electrons are transferred. When we say that something is a positively charged area, we mean it has less electrons than protons. There are 3 types of electrostatic charging. If you're writing stuff down, this isn't a bad place to do it. Conduction is the transfer of electrons through direct contact. There has to be one object touching another, and electrons from one go to the other. Friction is the transfer of electrons between neutral objects, making each object electrically charged. If you start out with two neutrals, you end up with two electrically charged objects. The last one is the trickiest. It's induction. It's a rearrangement of electrical charges on a neutral object. As we said, neutral objects have equal amounts of positive and negative, so it's going to rearrange them due to the presence of a charged object. That's all we're talking about. Let's start with the first example, electrostatic conduction. Okay. Again, you have to have an unbalanced charge. In other words, one of the objects they can't both be neutral to have electrostatic conduction. At least one of them has to be charged. It's instantaneous. I mean, it happens within a fraction of a second. And if the objects are small and they're isolated, they are going to share whatever electric charge there is. In other words, if they come into contact, charges are going to bounce back and forth until the amount on each is equal. I'll give you an example of what I mean by that. Say you have two objects. We have one that's positive 6 and one that's negative 4. If you look at them, you can see their total charge is positive 2. So if we put them together so they come in contact, we end up with a total charge between the objects of positive 2. But it's going to share that charge between the two objects. One is going to be positive 1, and the other is going to be positive 1. Again, that goes for things that have very small amounts of charge. We'll talk about grounding later, where it doesn't quite happen that way. That's what we're talking about next. You can see at the bottom left there's a picture of a 3-prong plug with the little grounding pin. That pin literally connects to ground, sometimes through your plumbing, sometimes through a rod driven into the ground, a grounding rod or a lightning rod. That is designed to take whatever excess charge comes out of the flow of electrons in your plug and put them back into the ground where it's safe. The symbol on the right is the symbol for grounding. It means the charged object is connected to the Earth. Now, the Earth is an unlimited charge donor. So let's say something is negatively charged and it comes in contact with the Earth directly. Well, at that point, the charges are all repelling against each other to start with inside the object. It doesn't. I mean, if they have the chance, they're going to repel against each other because that's what like charges do. And when you have and then if you give them a path through which they can go out, they will. The same is true for positive charges. If you have a positively charged object, then you just touch it to something, you touch it to the ground or connect it to the ground. Negative charges are going to actually go up so that it balances out the positive charges and you end up with a neutral object. That's what happens in grounding. Electrostatic friction. Objects begin as neutral, and one donates electrons. You can see the floor you can see the person over here walking across the floor. Kind of weird person. But you can see that as he drags his feet across the ground, he gets an electrical charge. He started out neutral, and he's donating electrons to the floor. Now, the floor doesn't show an additional charge because it's connected to the ground. But the truth is, the floor is becoming slightly more negative than it was before. The same is true with those rods on the middle right. When you rub them against a piece of fur or against a piece of wool, one of the objects donates electrons to the other, making each object have an opposite charge. They both start out neutral. Now, which one donates really depends on the material. I haven't seen a good rule of thumb for this object always donates to this one always accepts. It really depends on the nature of the two materials that come in contact. Electromagnetic induction is kind of a weird idea. Like I said, it was the most difficult to understand. One object starts out neutral, just like we show there. You can see it has 1, 2, 3, 4, 5, 6, 7 positive charges, 1, 2, 3, 4, 5, 6, 7 negative charges. It doesn't mean it has 7 electrons or 7 protons. It just means that the amounts of charge are equal. It's really just to that, so we can visualize what's happening inside there. We bring a nearby charged object to polarize the charges inside the neutral object. It doesn't come in contact. It doesn't transfer through conduction. It's just going to move them around. You can see we brought a charged object near it. It's positively charged. The little thing that looks kind of like a cap lid that's positively charged in red. And you can see that what it did is it attracted the negative charges to it. And it left the positive charges there on the opposite side. So now it's polarized. The charges are separated. That's what electrostatic induction is. Sorry. And now we're going to talk through the example. Sorry. You can see on the bottom it's neutral and it stays neutral. Now in the last example, we took a positive charge and we brought it near it, and the positive charges went to one side, and the negative charges went to the other. Well, in the middle example where it's connected to the ground, the negative charges all come near the positive object that's close to the neutral object, but the positive charges are nowhere to be found. Now, although they didn't technically go downward, although technically the protons didn't go downward to the Earth, enough electrons went upward that it's no longer neutral. It's got a charge of -7, equal to the number of charges that it had before. And then, if I take the ground away, well, there's nowhere for it to escape to. Now it's got that extra negative charge on it. And if you look, we can go. If we unattach the ground and then we move the rod away, on the right-hand side, you can see what happens. The charges just spread out inside the object, and it's now negatively charged. We use the positively charged object to make something negatively charged. We're going to look at an example that I started to get to with the electroscope. It says the electroscope is neutral, as evidenced by the... You might as well just watch this. Woo! I think that explains it pretty well. Here's another example, the balloon. Rubs on the guy's head, the balloon gets a negative charge, it goes over to the wall, and you can see that it doesn't make the wall neutral. It just means that the charges separate on the wall, and they move slightly away. The wall becomes slightly positive. Now, over time, when that happens, the charges do drift from the balloon into the wall, and the wall is connected to the ground, so eventually the charges neutralize, and that's when the balloon falls off the wall.